I see that it's already 3 o'clock, so let's start. And everybody, I guess, will the rest will join in a couple of minutes once we get into pace. So, hi everyone. My name is Julius, and I'm the founder and CEO of CloudWiser that is hosting today's webinar. We also have Tonis here from AWS who will be delivering the presentation. And Tonis, do you want to say hi to the audience?
Hey everyone, good to have you here, good to be here. Thank you to Julius and thank you to CloudWiser for inviting me. My name is Tõnis Pihlakas. I'm a solutions architect at Amazon Web Services. I'm based in Finland, and I mostly, for my day-to-day work, I mostly guide our customers on their cloud journeys in the Baltics and in Finland.
Yeah, you'll be hearing from Tonis a lot more today, and just before I'm pass it on to him, I want to first of all say that I'm very happy to have all of you joining this event, and I hope you'll find it interesting and useful. And before we begin, just let me say a few words about CloudWiser and what we do for those who haven't heard of us before. So CloudWiser is an advanced tier AWS partner, and we're operating in Lithuania, Latvia, and Estonia. And we work closely with AWS to support current AWS users in the region and, of course, attract some new ones. Our main business line is AWS resell that is being used by a number of companies in the Baltics. And so if your company is currently using AWS, I definitely suggest you check out the benefit packages that we offer as a bonus on top of what you spend on AWS. And next to that, we try to do a lot of things to build the local AWS community. And this webinar is a good illustration of that. And then Tonis will be our speaker today, and my role will be to support him. So before passing the stage to him, I want to mention just two things. So first of all, your questions are very welcome. Please submit them in the Q&A section, and we'll go through them after the presentation. And this event is being recorded, and we'll share the recording of the presentation with everyone tomorrow. So that's all from my side. Tonis, are you ready to take over?
Yes, I am. Give me a second.
Okay.
All right, I'm hoping that everybody can see the picture well enough.
Yeah, I see it. We can go on.
All right, excellent. One data point is good enough for me. So yeah, welcome to Databases on AWS, the right tool for the right job. So in today's quick presentation, what I would like to do is a couple of things. So first of all, give you an overview of how databases and how we think about databases and how we think about modern applications in general, and what is a modern application. Then have a look at the AWS database offering. So what kind of data models are out there? What kind of tools are there for you to use? And what kind of AWS services fit for a specific purpose? And then maybe give a couple of tips on how you can think about your workload, how you can think about modernization, or how you can think about your existing workload or a new application when you start picking the specific tools for your job, so the specific database services. And once this is done, I'm hoping this will take roughly around 45 minutes or so. We can get to the Q&A section, and questions and answers will not be recorded. So we will just record the first part of the presentation, and in case you have anything you want to discuss but don't want publicly available afterwards, then's a good time to do that. And I've already spoken a little bit about myself, so I would love to get to know more about you, who you are, what you do. And for that purpose, we've prepared a small poll. So Julius, maybe you can share that with the audience.
Yeah, sure. Sorry. Yeah, you should see the questions now popping up, and let's give a few minutes for attendees to share their answers. I see
So
that
yeah,
we.
in general, I have two things I would like to know more about you is, first of all, what you do in your current role. Are you more of a technical person, or are you more in the managerial role? And second of all, is a little bit more specific about relational databases. So how much knowledge or how much experience do you have with relational databases? So these questions just help me guide my presentation and messaging a little bit, and would be much appreciated.
Okay, so just a few more moments for everyone to tell their opinion, and I'm ending the poll, and I will be sharing the results. Do you see it?
I see it. Excellent. So most of us are technology folks here, and we've almost all of us know what a relational database is and what it does. So this is perfect. This is something I was expecting as well. Thank you very much for that. Right, but let's get on. Let's get on with the show. Now, the thing is, with modern applications and in this kind of a modern world, what we see are really three trends. First of all, we see that there's been a huge explosion of data. Essentially, about every 5 years, the amount of data that we collect, that we process, increases tenfold. And this is driven by not only your applications and not only your need to find out more about your users and collecting more data from your users, but it's also driven by different kinds of platforms that the users are using. So for example, smartphones, connected devices, Internet of Things, all of this fuels this huge, humongous growth. We see that on development side, we're moving more towards a kind of a microservice type of an architecture. So I don't want to use the term microservice too much because it's fairly overloaded nowadays. The way I think about it is that we try to section the way how we develop things, and we kind of try to develop things in smaller bits and in kind of smaller quantities. So something like microservices that work together for a single goal to provide value to end users. And this affects us not only on technical side, but also organizationally. So you want your small services delivered by small self-sufficient teams, and you want to give them freedom to pick their own tools and pick their own databases included. And we also see that there's a rapid rate of change, which is mostly driven by this kind of a DevOps culture that has been fostered for a while now. And this through the fact that we empower those small service teams, we get them a much higher rate of change in our development processes. And this also affects the situation quite a bit in terms of the choices that you have to make when you process data, for example. Now, to get more value from the data, 10 times as much data as it was 5 years ago, right? What are our customers doing? So one thing that we see them doing is that they're taking existing databases and they're moving them to fully managed database services. So customers like yourself, you don't want to really do this undifferentiated heavy lifting of managing databases and managing database servers, having to patch your servers, having to think about security aspects, how to secure the hardware, so on and so forth. You want really something that you can use and build upon to differentiate your business. We also see that in this process, customers are breaking free from legacy databases. So legacy databases, which, for example, have very punitive licensing terms, or which require very high upfront investments from their users. But the main central focus of our topic today will be modern applications and modern applications with purpose-built databases. So this doesn't only mean that we're talking about greenfield development here, starting a completely new application, but we can also think about taking an existing application and modernizing it. to work in this new reality. What is this new reality like? So what we see really from modern applications is that they're global. They have many, many users, millions of users often. User growth is a really common key performance indicator for businesses. And because the cloud, the public cloud is reachable globally, this drives this growth also in your user base. Data volume, we talk about terabytes today, we talk about petabytes today. There's no longer a simple small database running on a single machine somewhere in the corner. We see that businesses are often expanding their presence into new markets, and they want to be available globally, but they also want to be available, they don't want to sacrifice performance for this globality, for this kind of a ever-increasing user base. So we're talking about microsecond latencies when we talk about performance requirements, also that request rates hit millions per second. You know, your small application might not do that right now, but we see a lot of startups, for example, that get into this hypergrowth, which they need to be able to handle. As I mentioned, access is now ubiquitous everywhere. Mobile devices, IoT devices, connected devices like your maybe your home entertainment systems, or why not Alexa, for example. We see that scaling requirements are virtually unlimited. We always need to scale. We always want more customers, more business, more action on our platform. And all of this, like as you're building all of this, so businesses, they can't really invest millions of dollars up front to have this kind of a global infrastructure available for them. This model is just not realistic in 2020. Instead, what they have to do is kind of hedge their success a little bit by only paying for what they use. And you want to be able to have your business grow together with your consumption, and have your business, let's say, revenue streams aligned properly with the way how you grow. And we can talk more about that later in the Q&A section if you're interested. Developers, they want API access. They want API access because it's easier for them to use, and your customers, when they are using your services, again, API access is very important for them to be able to take whatever you're building and build upon it something else. And development should be focused on differentiation, should be focused on something that makes you different, makes you a special player on the field, rather than putting a lot of effort into building something that others would have to build also anyway, like setting up servers. Now, to handle the kind of the data layer below all of it, we believe in database freedom. We believe that whenever you want to use a database, you should be able to pick a database, and you should be able to get the database at a reasonable cost, at a pay-as-you-go pricing, but at the same time not sacrifice security, availability, scalability, reliability. And for that purpose, we have multiple different data models that we will talk about, and talk a little bit about how they fit for specific purposes. So we can always start with a good old one, the relational databases. As I saw, I think 99% of us know about relational databases. So the relational model, an excellent model for when your business needs its referential integrity, when it needs ACID compliance, which is atomicity, consistency, isolation, and durability, from your data model, right? And what we see for use cases, obviously, there are two kinds of areas of use cases. So what we kind of prefer to see is maybe a little bit more on the enterprise resource planning, customer relationship management, finance side. Essentially, workloads that require to analyze the data as a whole. And one of the things, of course, that we see, as I mentioned before, lift and shift. the cases where you take an existing database and you put it into a managed service, and you already win a lot of by just doing that. But of course, another thing that is evident from the fact that relational databases have been the norm over the last 20, 30 years or even more, is that the relational database becomes a sort of a golden hammer. It becomes this thing that everybody uses for everything. And it is often hard to tell someone that, you know, you should be using multiple different databases for your workloads. But this is something that needs critical thinking. It needs a little bit of critical thinking from architect side, from everybody doing the building. And whenever you see that someone is sort of pushing relational model on you, saying this can do everything, just take a step back, use some critical thinking to see what the reality is. And one of those first kind of data models that popped out that was a little bit of different from relational was key value. So back in the day, we had at Amazon, we had a lot of scaling issues with, or kind of scaling challenges, let's say, with relational databases. It was really tricky to scale them over a certain limit of size and number of transactions per second. And from that effort to innovate, what came out was Amazon DynamoDB. So from AWS service part, we can go deeper into those services as well if you really want to. Afterwards, just leave a comment in the Q&A section below. From relational database side, we have two services. So I'm just going to jump back for a second here. There's Amazon RDS, or Relational Database Service, which provides you with managed access to 5 more common databases. So first of all, PostgreSQL, MySQL, MariaDB, SQL Server, and Oracle with pay-as-you-go pricing. And there's another companion service there called Aurora, which is a PostgreSQL and MySQL compatible relational database service that has better performance and also better availability than your out-of-the-box RDS database. For key and value, DynamoDB, but what kind of differentiates key and value from a relational is this kind of focus on higher throughput and low latency reads and writes and scaling pretty much endlessly. So key and value model is a model where you access data based on a specific key value, specific key. So you map keys to values. So like for a programmer term, like something like a map, very big and highly scalable map structure. The important bit there is that you have to design those key value stores very specifically with your use case in mind. So for example, if you read something, you really want it to be read by a single key value, by value of a single key. And at the same time, you want to make sure that you don't end up in a place where you're just mimicking a relational data model with a key and value store. So one of those examples where you would pull something out of a relational database or a existing relational data model to a key value store is if you see that in your relational database, you're doing a lot of reads that are being optimized. So one thing that I've seen is we tend to do, for example, denormalization into tables. We do primary key lookups, and we want to denormalize everything into a single table so that the read for that table would be really, really fast. And instead of putting that additional burden on the relational database, it might be better to pull it out and put it into a key value store because it's just the natural use case for a key value store. Other examples include real-time bidding, shopping carts, social, for example, instant messaging that's being used, customer preferences, things or use cases where you need access to a very limited set of data very fast. And also where you need to write a limited set of data very fast. A little bit of an extension on top of it, or a kind of a sidetrack, is document databases. So for document databases, we're talking about storing documents quickly, efficiently, and being able to access documents and query for documents on any attributes that those documents have. So when we talk about documents, we really mean JSON. And JSON has become this sort of a de facto standard in the industry for serialization, for data transfer. And for years, we've been struggling with having to, we process JSON on, let's say, front-end side of our applications, and then we need to somehow serialize it into databases. And we do that using either our own custom logic, or we might be using object relational mappers, but it's just not it. It just isn't that easy to maintain and work with. So for that purpose, there are services like Amazon Document DB, which is a MongoDB 3.6 compatible service for storing and retrieving documents. But another one where that might fit into this category as well would be Elasticsearch. So Elasticsearch allows you to search for documents and kind of really focuses on the searching aspect of your document store. We see documents being used in content management, again, personalization, everything where you use mobile, let's say mobile or clients to directly push data into your stores. So it's so much easier to work with data that's coming in JSON format and that you persist in JSON format. It makes it much faster, makes it much easier to work with. When you see when you think of your relational model, so when would you take something out of a relational model and put it into a document database? Usually what I would suggest is think about cases where you have, for example, a relational, let's say in your relational database system, you have a table that contains a huge number of columns that most of them are nullable. So this is something that we see sometimes. Over the time, you accumulate, let's say, new attributes that are attached to your entities. And, relational databases aren't good for that specifically. Their strengths are elsewhere. So instead of doing these really wide tables, take this information and store it in a document database. Another option that you sometimes see is maybe content management systems or something like a content management system where you have tables of, for example, key value pairs, so that you have a relational table with, let's say, one column called name and another column called value. And again, this is just a workaround for having flexible attribute schemas and schema on read. Or alternatively, let's say if you have very hierarchical data, multiple layers of documents, again, something that a document database can handle fairly well. Now, what if, key value stores give you this single millisecond latencies? But what if this is not enough for your business? You need faster latencies. You need lower latencies. You need to be able to query by key, but within the ballpark of microseconds. For that purpose, in-memory stores are there for you. So Elasticache with two options, either Redis or Memcached, will provide you an in-memory store that's very close to your compute and allows you to access your data quickly. Another option there is Dynamodb Accelerator. Again, not quite a key value store fully. I mean, it's a key value store that mimics DynamoDB's API, so it's really easy to go into and start using. But at the same time, you will get lower latencies than with a regular DynamoDB query, so microseconds instead of milliseconds. We see it mostly we see it used a lot in gaming, in leaderboards, or real-time analytics, or caching, for example. And the caching is also a good use case for having like a companion database to your relational database. So, for example, if you have queries in your relational database that are still fairly complex, they don't fit a key value store that well. but you see that your customers are using those often, and you don't want to, or you haven't had the chance to build a read model that would quickly service those queries. You can have those queries cached and the query results cached in an in-memory store, and win some precious milliseconds from there. For use cases where you have a high number of relationships between data and very complex relationships between data, you might think that relational model sounds awfully like it should work then, but it tends to be that if you're looking at something like a social network, or you're looking at something like recommendations or fraud detection, where you need to be able to quickly query this data and very flexibly query this data of relationships between entities, and finding, let's say, long chains of relationships between entities, graph databases tend to work better. And for graph database, from graph databases, there's the AWS Neptune. Neptune is a graph database, that fully managed graph database that lets you quickly and easily create and manage these relationships between data and query them with standard tools. Now, for some use cases, we mentioned IoT devices and kind of smart devices that might push a lot of telemetry information, or sensors in your home, or somewhere else in a workplace. Relational databases, again, have been used for time stream data, but they often don't have the tools, or you don't necessarily need to put the burden on a relational database to keep time series information. For that purpose, there's Amazon TimeStream. TimeStream is now generally available, which I'm glad to say. A very recent thing, but I'm really happy that TimeStream is finally out and available for your use. You can collect, you can store and process data that is sequenced by time. So we're mostly talking about measurement data here, and analyze this sort of a measurement data using statistical functions, for example. Now, for cases where you need a sort of an insert-only store, later databases come to play. So for cases where, let's say, you need to record a number of events that have been happening, and you need to be able to verify that these events, this event information has not been tampered with. So, for example, you're building a registry of some requests, let's say official requests. You're building a healthcare system. You're building a financial transaction log. You want the data to be really cryptographically verifiable, that in a sense that it hasn't been changed, and you're able to track this fact reliably back in time as well. So essentially, complete, immutable, verifiable history of all changes is where leisure databases are used. And for that purpose, we built Amazon QLDB, which is a fully managed leisure database. And so, for example, customers are using it for all sorts of, let's say, use cases where they need to track this kind of an event history in a reliable manner. Now, the final one here, again, for applications that require high-speed data processing and also those single-digit millisecond latencies, another option is a white column database. So a white column database compared to maybe a key value database, there's a little bit of a difference in between. So white column looks more, or kind of, let's say, feels more like a big table of rows and columns that you can access in different patterns and in different ways, where you so that you can optimize, let's say, your use case for a certain set of columns from a certain row being retrieved very fast. As opposed to maybe a regular key value store like Dynamodb or Amazon S3, where you're accessing perhaps the whole value at once or in one go. With wide column databases, you might be accessing, let's say, groups of columns. Example here, so service here would be the Amazon Key Spaces, which is a managed Cassandra offering. You can build different low latency applications on top of Key Spaces and have it managed by AWS. Now, we've gone through this whole set of databases, and you might think, okay, which one should I pick, and how should I approach this this question even? So first of all, let's look at a few customer examples here. First, FINRA. FINRA is an authority in the U.S. who follows the New York Stock Exchange to make sure that all the stock exchange transactions are fair and works as a regulation authority. They use different kinds of databases based on the purpose. So you see that if they have massive data volumes and need quick lookups, they're using Amazon DynamoDB. For session state, Amazon Elastic Cache. So whenever users come to their website, use it, they need sub-millisecond site rendering ability. And for that purpose, Amazon Elastic Cache is great. Data collection, document DB. As I mentioned, it's easy to ingest documents in already a format that you can persist into a database. Fraud detection, Amazon Neptune, the whole graph database for understanding how relationships between data could be treated or could be viewed as fraudulent. And finally, for relational databases, Amazon RDS and Amazon Aurora. Mostly for their primary transactional workloads and having this referential integrity in place. Another customer, Airbnb, you see a similar pattern here. If there's a search, if there's a need for a quick lookup, Amazon DynamoDB, you need sub-millisecond site rendering, Amazon Elastic Cache, and RDS for relational data. And a very similar picture, for example, with Duolingo as well. So Duolingo provides a language learning experience for 300 million users, and they do 7 billion exercises per month. They want to be able to give anyone the chance to learn a language for free. And they do this by tracking their language exercises and the language exercises that have been done through DynamoDB, using Aurora as the primary transactional database for user data, and using Elastic Cache as for instant access to common phrases, common content. Okay, now let's talk about the mindset, and something that I would recommend you to think about when you look at your data and try to understand what is the data like, and what kind of questions you should really ask from yourself or from your architects or from anyone else who's familiar with your use case. And I would like to look at it, I would recommend you to look at it from three aspects, from the aspect of shape, size, and dynamics or speed. So first of all, the shape of data. What are we talking? What do we refer to as a shape? So for example, how do you look at the data? How do you keep the data? Do you operate on records or do you operate groups on records? So for example, a payroll use case. So if you work with groups of records, then it tends to be that row stores are a good candidate for your use case. Now, another option here is that you're really working on aggregations. You're doing analytics, you're doing scans, you're joining data, you're doing scans on, let's say, a few columns in a table. And in those cases, column stores work great. So one of the column store services we didn't mention is Amazon Redshift, which is a PostgreSQL compatible data warehouse, which scales to petabytes as well, which you can use for these aggregations fairly easily. It feels like a relational database, but it has a different kind of a data store structure behind it. And a good example workload for this kind of a shape would be analytics. Now, for workloads where you need really querying by key, doing fast ingestion, doing high throughput, key value stores are excellent. So for use cases like tracking devices or storing your gaming sessions or maybe looking up products from a product catalog. Then document stores are a good example for if you want to just index and store documents and query them in a flexible way. So for example, if we take patient data or we take content management systems, document stores are a good match for those. The idea there is that you will get these large documents of data or structures of data out of the database as a whole, and you don't have to build your data model such that you are running around in different tables or different data stores to look for the data and to aggregate this data together. If you're working with relationships and your data shape is more in the shape of, let's say, entities and how those entities interact with each other or how they relate to each other, then a graph store could be a better option here. One example, recommendations. So again, with all of those, feel free to leave a question. We can go deeper into any of those models and explain a little bit the services behind there. And if you see, so for recommendations, for example, if you have a really good hypothesis on how you would recommend something to a person. So for example, it's not just a machine learning algorithm that does it based on previous examples, but it's, you know that if customer A watches sports and purchases product X, then customer B, who also watches sports and might also be interested in that particular product. And those kinds of queries are fairly easy to construct on graph stores, graph databases. If you process sequences of data, especially sequences of measurements, time series stores work well for you. So any kind of telemetry, any kind of Internet of devices or sensor data works well. And another use case here, get and put of objects. So for example, if all you need to do is just get and put a large object by key, then unstructured stores like Amazon S3 or simple storage service work really great. So for example, here, storing user reviews, storing user provided documents, and let's say in any format other than JSON. For this, an unstructured or an object store works great. Let's talk about size. So one thing you need to consider is, are we talking about a bounded data set or a virtually unbounded data set? And if you might be working with both. You might have a few data sets that are bounded and few data sets that are growing, ever growing, and there might be a need to have different database engines for them and having different database data models for them. So for example, a number of employees might be fairly bounded by your ability to hire and by the ability to kind of employ. And at the same time, the number of sensors, if you're selling those sensors and you're installing them in all sorts of different devices, and the more customers you have, the more sensors you will have, this is effectively an unbounded data set. And as those sensors start producing data, you need to take into account that the data volume is growing through time. Working set size and caching. So are we talking about a case where you have sales data, let's say, that needs to be kept around for 10 years for regulatory purposes, but it's mostly cold and only the last 12 months are queried? Or are we talking about session data for a streaming service that needs to be accessed in microseconds? So when we talk about, let's say, these large data volumes and cases where, for example, a lot of the data sits around cold, it might also be the case that that one data model doesn't work for you, and you're better off with a data model where some of that data, let's say more actively queried data, is kept in a specific data model. So for example, columnar store on Redshift, and the rest of the data is available in a cheap object store such as S3 or Glacier. So, you know, something to think about. Not only to think about the specific database that would do the work, but also what's surrounding the database. When we talk about retrieval size, does your use case need you to, or require you to fetch 1 row, or do you need to fetch 1,000 rows? And if you need to fetch 1,000 rows, is this what kind of a use case is this? Is this a valid use case for a database, or is it more of an ETL job? Or again, something to think about. Think about what surrounds your data and how you can best address the user's needs with multiple tools. And finally, on size, is this size something that you can split apart? Is the data partitionable, or is it monolithic? Partitionable data, so for example, car location data that you can partition by cars, or maybe some other factor that kind of includes cars, but the idea is that the data can be fairly equally sort of spread out over different partitions, and you can access it quickly and in a distributed manner. And if your data doesn't have a natural partition boundary, so maybe payroll data as a whole that you need to analyze, again, a different data model might work there. So you might have to look at a data warehouse like Redshift or a relational database for that purpose, and for highly available and low latency data access for partitioned data, something like a key value store could work. And finally, the speed or the dynamics. What do you do with the data? Do you compute? Do you run any compute on the data? Do you just get it from somewhere and put it into a store, and you need to do it really fast? Or do you need to get the maybe run an analytic function or analytic processing on top of the data? Rate of ingestion. Is it that you know, telemetry from cars are added to the database every minute, every second? Perhaps your sensor data is very critical, and you need to be able to access it within a matter of milliseconds, and run an analytics on top of it within a matter of milliseconds. Or is it that every time you get a new employee, their record is being added to the database? Rate of change. Do you actually change the data, and what do you do with the changes? Like how do you change the data? If you're frequently updating the data, certain data models might not work well for you. So a ledger database might not be the perfect data model. At the same time, you might have sales records that are never updated, and in those cases, a reliable insert-only store works much better. Throughput. So how do your users access the data? Are they looking at every second? They're looking, maybe there are 1 million users online, and they're browsing the product catalog, and you need really high performance at a high scale. Or is it that you have a low number of users, but they're looking at very, let's say, large documents, large sets of data at a time? So perhaps 300 patient records per day, which also include maybe X-ray images and additional, let's say, attachments, all the patient history and so on that they need to look as a whole. So you might have throughput in terms of very high number of transactions per second and low data volumes per each transaction, or you might have a different kind of a throughput that you have small, like a low TPS, low number of transactions per second, but a very high data volume on each transaction. And finally, latency. Do you need the location of a car in a few milliseconds, as we mentioned, or is it okay for you to wait 5 seconds for this analytical query to process? And those considerations need to be taken into account when picking your tool and picking your database. But all in all, first of all, as we looked at the picture, try to optimize and try to think in terms of optimizing for what you do most often. So a little hint here, if you're using databases, mostly what you do is reading. So you usually would optimize for reads, and you would take existing, you would take data models, and you might create parallel data models to optimize for specific use cases, for specific read use case types, let's say. And this is something that has changed over the time. So if you have mostly experience with relational databases, historically these were built so that you would save on storage, so that you would kind of compact everything into minimal amount of storage and save on throughput and put more effort on compute. Nowadays, storage is cheap. Storage is very, very easily available and readily available and fast. So you need to think more about how do you optimize the compute side of data processing. So think about shape, size, and speed, as we spoke about. Maybe that will help you to get to a good answer and to try out something that works well for your use case. And speaking of use case, work backwards from it. Try to understand what is it that your customers need, what kind of access patterns do they have to the data, also what kind of data do they bring to the table and how they bring it. What is the, for example, throughput? What is the expected temperature of the data that you're keeping around? Are you keeping large amounts of data that you almost never access, or is all of your data all the time being updated and accessed? And don't forget, run experiments. Whenever you feel like asking, hey, is this tool right for me? Just try it out. It's you pay as you go. You don't need upfront investments, large upfront investments into hardware or building your data center. Just run it. If it doesn't work, forget about it. Try something else. Embrace the freedom of choice. You have a lot of databases to choose from. I've only covered a few here, and there's a lot more there to be discovered, not only in the AWS offering, but also in the AWS marketplace. Find the right tool for you, and use all of the previous knowledge and previous what you learned from previous to find something that fits your use case, and then go build. All right, thank you. Now let's switch to the Q&A section, and for that purpose, let's stop recording.